Okay, we are now starting. We're going to start taking off exactly on part two. And where we're going to take off now is the relationship between air masses and fronts. And I'm going to show you that obviously we're going to see that we're going to connect that on weather maps. We're actually able to now track air masses and actually identify the boundaries between them. And the boundaries change on a day-to-day basis because the winds move the air masses. But between traditional weather maps with these blue and red lines, which we'll talk about here shortly, or even the more dynamic looking satellite images, we now almost can track like a wild animal how these air masses are moving, and this is what gives us some insight on how to predict weather and where it's going to be rainy or where it's going to be clear skies. And that's our goal here, is to show you that we have a variety of ways of communicating how these animals almost like animal-like weather systems move. So air masses, you've got that maritime tropical air, and it could push up from the south, or we got continental polar air masses invading in from the north. Well, we've got a series of tools that we use and now can track these dynamic movements to predict weather. Now we're talking about air masses and what happens when air masses move. Uh, Continental polar air is basically an invasion of cold, dry air from Canada. So cold, dry air from Canada, or even colder air off of the North Pole, which is continental Arctic air, when these air masses move in from the northern latitudes and they begin to push south, we will find out that this is what creates a cold front. These create colder, drier air, and these generally are more stable conditions because without the humidity, the air behind or associated with continental polar or continental Arctic air simply doesn't have the humidity to create unstable conditions and big thunderstorms. So these CP air masses are very common in Canada, and then they very often in different times of the year can be pushed to the south and invade into the Midwest. And when they do, we associate them with cold fronts and cooler, drier air coming in. And this is what it looks like on a weather map. On a weather map, we would see a blue line with the teeth on them, and we would see as that blue line pushes down through there, cities like Minneapolis, St. Louis, and Birmingham, Alabama, they're all in different stages of being invaded by this continental polar air. Initially on January 1st, the CP air was where it should be up in Canada, but within 2 days later, the CP air and the jet stream drove it so far south that the CP air had invaded all the way down near the Gulf of Mexico, and you could see how it effectively, when continental polar air invades, it actually brings much cooler, drier air in, and you could see how it would be affecting all three cities very differently. But obviously, Minneapolis, Minnesota, being so much closer to the source region of CP air coming out of Canada, it was influenced significantly so much more by the continental polar air than, say, Birmingham, Alabama, being much closer to the maritime tropical air. Maritime polar air and continental tropical air masses, if I were to show you, they're very different because they're not air masses that so much frequently affect the United States. And obviously, I think it'd be better to look at them if I was to show you them on a weather map like I've shown you before. And I'm going to go back to the map here. Maritime polar air is clearly the air masses of the Pacific Northwest or the Northeast. So if you lived in New England or you lived up near Seattle or Portland, Oregon, these bring cool, wet conditions, and by the fact that they're kind of affecting the northeast and northwest corners of the country, these air masses, either because of mountain ranges or because of air circulation issues, they don't penetrate to the middle of the country the way maritime, tropical, and continental polar. But if you were to move to the Pacific Northwest or New England, you would understand why the conditions there are often very cool and very humid, and often that leads to very overcast, cloudy conditions. And so if you're a lover of cool, wet air, overcast, overcast, sort of dreary weather. That's why maritime polar air is a very, very popular weather to drink coffee in. And you can understand why Starbucks coffee started up here in the Pacific Northwest near Seattle. The climate up there was very conducive for that. The other one here, continental tropical, again, kind of comes out of northern Mexico and is a hot, dry air. And this hot, dry air typically invades and moves into the desert southwest, helps produce the Mojave Desert, and it's a very warm air. But because it's so dry, coming from the middle of the desert, or coming from the southwest in the middle of the United States, it tends to not have as much moisture, and it tends to be fairly stable and produce a lot of dry conditions, hot, dry conditions. So this continental tropical air is actually the exact opposite of this maritime polar air. Very cloudy, very wet, humid environment. Continental tropical air tends to produce very warm, clear sky days. Often it's the air mass that helps produce deserts. So again, these air masses are really affecting different areas of the country, and either because of mountain ranges or because of the movement of the winds, they don't as regularly penetrate the middle of the country the way CP and maritime tropical air do. And that's why I'm going to go back and talk specifically more about maritime tropical air, because the story of the Midwest in Tornado Alley is really primarily driven by the interaction of CP air and maritime tropical air kind of regularly colliding. And not to say that continental tropical air does not play a role. It does play a role, but it takes special events where we can kind of see all three air masses kind of colliding here in the Midwest. But on a day-to-day basis, if I'm in the middle of the United States in Illinois or Indiana or Iowa, we're probably talking more regularly about CP and maritime tropical air kind of influencing our day-to-day weather oscillations. So we're back now to the presentation, and I'm going to probably have this presentation going in 3 parts now. Maritime tropical air, obviously, as you saw, is the other key player for the Midwest, and its source region is the Gulf of Mexico. And this is what brings us the warmth and the humidity that we need to produce big weather, big storms, atmospheric instability, where we have a lot of buoyant air that wants to rise and lift. And maritime tropical air, I would call it's the energy. This will be the key energy source that creates our weather in the Midwest, and it's really the mixture of maritime tropical and the continental polar air that really creates the dynamic which we're going to talk about, which are fronts. So I'm going to break the air masses and fronts. Now that we're really now set up to talk about fronts, I think I'll stop this presentation right here, and we'll have 3 different videos, and the next one will just target what is the weather associated with warm fronts, cold fronts, stationary fronts, and how these all air masses relate to one another with producing weather associated with fronts, and you'll begin to understand the framework which leads to severe weather and thunderstorms, which is often a fascinating topic to many students.